This is a simple trig equation involving the cosine function. We have to solve cos x equals a half, and we're given the interval minus 360 degrees to 360 degrees. So we're only going to accept solutions if they're in that interval. Make sure your calculator is in degree mode before you continue. To solve this, we need to first find the principal value, and in this case it's the inverse cosine function of a half. Your calculator or your memory should tell you that this is equal to 60 degrees. We can find the general solution from this. There is a formula. The general solution for the cosine function is 360n plus or minus the principal value. So very simply, we substitute values of n into here and check that they're in the correct interval. N is 0 will give us x equals 0 plus or minus 60. So the two values are minus 60 and 60. With n is 1, we're going to get 360 plus 60. So that's going to be 420, or 360 minus 60, 300. Okay, so that one's okay, that one is not. If we do n is 2, we're going to get values of 720 plus or minus 60. They're going to be too big. So let's look at negative numbers now. With n is minus 1, we will get x is equal to minus 360 plus 60. So that's minus 300 degrees, or minus 360 minus 60, that's minus 420 degrees. That one is okay, that one is not. With n is minus 2, we will not find any further values in the interval. So we'll write out our solutions from the smallest to the biggest. So the only solutions we found were minus 300 degrees, minus 60 degrees, 60 degrees and 300 degrees. 4 solutions. You can check they're correct by substituting them back into the original equation and proving that they're equal to a half. In this second example, we have another equation with cos x. This time we have to solve cos x equals root 2 over 2. We're given an interval given in terms of pi. That means it's a radian problem, so check your calculator is in radian mode before you continue. We need the principal value to begin with, so we find that using the inverse cosine function. So it's that, and the principal value in this case is pi over 4 radians. The general solution, the formula is this. So instead of 360, it's 2 pi n plus or minus the principal value. So now we have to try different values of n and see if the answers are in the correct interval. So with n equals 0 in here, we're going to get 0 plus or minus pi over 4. So the two solutions we'll get from this are minus pi over 4 and pi over 4. Only one of them is in the correct interval. If we try n equals 1, this time we'll get 2 pi plus or minus pi over 4. So that means the two values of x that we'll get from this are 7 pi over 4 and 9 pi over 4. Okay, 2 pi over 4 plus pi over 4 is 9 pi over 4. 2 pi minus pi over 4 is 7 pi over 4. So we keep going. They're both okay. They're within the interval. With n equals 2, that gives us x equals 4 pi plus or minus pi over 4. Now if we do 4 pi plus pi over 4, the answer we'll get will be outside the interval. It will be too big compared to that one. If we do 4 pi minus pi over 4, that's okay. That will give us a value within the interval, and it will be 15 pi over 4. If we do n equals 3, we'll be doing 6 pi plus or minus, so that's way too big. Likewise, any negative numbers will be smaller than 0. So we've got our complete set of solutions, so we'll just write them out in order. So x is equal to pi over 4, 7 pi over 4, 9 pi over 4, and 15 pi over 4 radians. You can check these solutions are correct by substituting them back into the original question, and they should be equal to root 2 over 2, which is about 0.707.